Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will show you that how to perform NDVI temporal trend analysis using Google Earth Engine. I will try to show you that all of step by step work. So then I hope we can easily monitor the NDVI trend over a period of time. Not only for that, I also show you that how we can easily create the beautiful style chart and trend line perfect for your research or project. Let's get start. So first of all, you need to import your study area. So in this case here, I already I digitize my study area. So this is my shapefile boundary. So for this boundary, I want to check for NDVI trend analysis over a period of time. So first of all, I already create this shapefile boundary. So now just need to import the satellite imagery. So if you want, you can use either the Landsat or Sentinel. It depends on your work. So in this case, I want to choose for this satellite imagery. So this is for Landsat surface reflectance satellite imagery. So this data set, just I copy the Earth engine snippet from here. Just I copy this Earth engine snippet and further just paste here. So now it is stored in a variable. I give a variable name. So just put the name, suppose L8. So now this L8 is my variable name. So this variable stored the full image collection of Landsat 8 surface reflectance. So now first of all, we need to filter for our specific boundary. So for that, just use here the filter bounds function. It intersecting with the whole image collection for your region of interest. My region of interest is that ROI. So just put here the ROI. And now also filter the time period. So I want to make the temporal NDVI trend analysis, suppose from 2015 to 2025. Okay. So just I put here filter date, suppose 2015 1st January from 2000, suppose 24 December 31. So I take this time period. So now if I check how much image collection is available, so if I just print and call the L8 and use the size function, so now we find out that total number of image collection between this time period. So we find out that 380 image collection we find out in here. So now this image collection, we need to convert the DN to top of atmospheric reflectance. Okay, we need to just convert. So for conversion, they are already give the scale and offset value. You can see this is the scale value and this is the offset value. So this scale and offset value I simply use, and then further I convert DN to top of atmospheric reflectance. So let's go try to do it. So for that, just I create a function. So I put the map function for connecting overall collection and create the function keyword and put the name element, suppose image. So now I just put my argument. So my argument is that I want to convert DN to top of atmospheric reflectance. So for that, just take a variable, suppose TOA, and now just call the element name image, and these things multiply with the scale. This is scale value. If you check the scale value, this is the scale value. Okay, just I copy the scale value and then paste here, and also add with offset value. So this is the offset value. So basically this region we need when you convert DN to TOA, meaning top of atmospheric reflectance. So just I paste here these things, as well as I also want to create the normalized difference using this top atmospheric reflectance, mainly NDVI I want to calculate. So just I do it for the same line, same function I try to use. Just take a variable NDVI and call the TOA, this variable, and apply the normalized difference between two band SR B5 near infrared and red SR B4. Okay, just I make the NDVI and also rename it. So just use here the rename function, rename as NDVI. So just I calculate the NDVI. So now what I return from here, so just I put the return NDVI, this variable set with system time start. So just put here system time start. Okay, and then also this image basically this is my element name. So this image get from according to the system time start. So I define it. So now I create a function. So this function basically, first of all, I have total 380 image collection. This 380 image collection I just convert into DN to top of atmospheric reflectance. For that I simply multiply this scale value and also add with the offset value, and then simply normalize difference between the two band, near infrared band and red band, and return the NDVI system time start, and also this image also get it from the system time start. So it's one kind of function. So after creating this function, we need to move to the second step. So now we create a time band for regression. So it's important about that. Create the time band, okay, for regression. Okay, so let's go try to create the band for regression. So just I take a variable. Suppose I put the variable name is that with time and call my collection, which I already create L8, and in this collection I already calculated the NDVI. So just now I just create the time band for regression. So just using the map function, and after that create the function keyword and put the element name, suppose img. So now I just create the band of time. So take a variable time, and then I put here ee dot image dot constant ee dot number, call the element name image dot date, and then use here dot reference, put the time period ee dot date, and put the date. Your first time is that 2015 1st January. Okay, just I put here 2015 1st January, and then put here the year. Okay, yearly. We just create the band for yearly. So after that, just use here dot rename function, and then I rename it as a time, and I put a float. Okay, just put the float. So after creating these things, we just return. So just put here the return. So return this element name image add bands with the variable name time. Okay, so now it helps you to create the band of time. So now linear regression, we need to calculate for the per pixel. Okay, so let's go try to do it. So we put the linear regression per pixel, we compute it. So for that, just take a variable, suppose fit, and now call this band name with time, this variable name, and paste here, and select from here basically two band we already create for the time, another band is for NDVI. Okay, and then we are just apply the reduce function. Then how I can reduce, earth engine dot reducer dot linear fit. Just use this function to create the linear fit. So let's go. Now we try to display this result. So for that, just use our map dot add layer, and also call this fit. From this fit, basically we just need to select select the band of scale. So basically when you put the linear fit, we find out that one band is the scale, and then this thing just clip with our study area, basically ROI we define. Further you can just make the visualization. Suppose mean I put suppose negative 0.05, and max I put suppose positive 0.05. Okay, this way I simply put. If you want, you can also add the plated, just make the list of plated. So I put the list, suppose red, it indicating suppose vegetation decreasing day by day for the red pixel. Then then I put here suppose white, then I put here suppose green. Okay, just I put this type of 3 color. Okay, so now if I just run the code, you can check here, it created another layer for linear regression per pixel. So it's loading. Okay, so it's appearing. So now this type of red color is indicating about that vegetation loss area. Okay, so we find out the this type of place, we find out that trend is negative. Okay, negative trends means that vegetation decreasing day by day, and this type of green color, it's indicating about that positive trend. Okay, positive trend means that vegetation increasing day by day, and this type of place we find out the red color indicating about the vegetation loss area day by day. So we find out this type of place, and this type of green colors in indicating about then vegetation gain area. Okay, and this type of is the vegetation loss area, and green color vegetation gain area. If you want to check the value, suppose just click on the inspector tab and click on this type of green color pixel, we find out the positive result. You can say the scale value is the positive. But if I just click on this type of red color, so for the red color we find out that scale value is the negative. Okay, so this negative trend indicating about that vegetation decreasing day by day for this type of coordinate, and this type of green color pixel we find out the positive. It means that for this type of place we find out the vegetation gain, not much gain. So if you find out that high positive value, it indicating about the high gain, low positive value indicating about the low gain. Okay, so this is the way to create this vegetation trend using the linear fit equation. So basically you can see this is the linear fit function we try to use in here, e reducer dot linear fit. So linear fit, in this time we are just put the two band in here, time and NDVI. So for any regression, not only for the NDVI, you just apply the same process, but for that you need to create the band of time. Okay, we need to create the time band for regression, And another band we already create. So this is the band for NDVI because I want to apply the regression for NDVI. So that's why I already create the band of NDVI in here. So then further just create the band of time. Okay, then further we can apply the linear fit reducer.linear fit this function and apply the time and NDVI. So from here you can easily find out this type of result. Okay, so now we find out that this type of result, and now I want to check for the trend line. Okay, I want to display the trend line and also check what happened. Okay, vegetation increasing or decreasing, we can easily identify day by day. So for the trend line, we need to create a chart. So this chart I already write in here. So this chart basically we are just apply the UI chart dot image dot series this function, and further image collection basically L8. So it is stored the image collection with band of NDVI, and then region basically ROI. I want to calculate the average scale value basically 30 meter, and further we add some option. Okay, basically okay, let me run the code and show you the result for. Just I run the full code. Just run the code. So now it create, and we also add the trend line about that you can see. So for the trend line, we add the linear trend line and also color, also line width of the trend line, opacity, visible in legend, show R squared value. Okay, so just add this type of argument, as well as you also try to add the different types of style for creating this type of chart, such as title, we add this type of symbol, font size, bold, color. Okay, for X title we also add this type of things. Okay, or Y level we also add this type of things. Okay, and finally we add this type of line color. Okay, or background color. Okay, this type of color you can also change further, and you can see the legend position in the chart we put the bottom. If you want you can also put the left side or right side. Okay, you can see the text style, we can also put the font size 12, font color, this type of color we try to put in here, and for the trend line, and further it display this type of chart. So we find out this type of trend chart. So if you look the trends chart, we find out that for this study area, vegetation is decreasing day by day. We find out that you can see vegetation is decreasing day by day. Okay, for this study area. So this is the way. Further you can also download this chart from here, download the PNG file format, and also download the CSV file format for the data. So this is the way you can just apply, and you can easily compute the trend line for vegetation trend analysis. Not only for the vegetation, anything, any trend analysis, just apply the same process using the linear fit model. I hope you can also learn something from new from here, and if you have any question, just simply make the comment. I also give the answer. In the meantime, I also give your announcement for upcoming online training program. So basically this class will be start from the 16th May, and our registration is the now opening. So if you want to join this online training program, you can learn all of those from beginners to advanced level on Google Earth Engine. And if you have no knowledge about the coding, if you have no knowledge about the JavaScript or Python, or if you have no knowledge about the Google Earth Engine, don't worry about that. In this online training program, you are able to learn all of those from beginners to advanced level. So as a beginners, you can easily start the journey with Google Earth Engine from this online training program. So you can easily learn all of those. So this class basically total 7 days class. We take the class only Friday and Saturday in a weekend, and basically 3 hours this live training program. And we also take the class on the Google Meet. You can easily get all of information from this website I already added. If you want, you can also check it, the video description, you can also find out from here. So you can also check all of course content for the first day, second day, third day. So basically 3 hours live training and 1 hours for the problem solving. Each day you find out the 3 hours live training and 1 hours for the problem solving class. So first class will be held this time, second class, third class you check all of time period, as also check all of those course content. Okay, and when you join this online training program, you can get some benefit, such as you can get the course certificate after submitting all of assignment. You can get all of course material, mainly slide or PDF. You can get all of practice code. You can get the recorded session. If you miss any live session, you can easily get the recorded session. You can get the lifetime teaching support. It's very important because as a beginners, when you start the journey with Google Earth Engine, you face lot of problem. So that's why you need the continuous support to learn the Google Earth Engine properly. So that's why we are also providing the lifetime teaching support after completing the total 7 days online training program. When you face any problem, any issue in your code, you can get the support for lifetime. And also research collaboration. So if you want to publish any scientific paper regarding this type of topic, because it cover a lot of topic, lot of remote sensing application we try to cover. So if you are interested to publish the scientific paper regarding this type of topic, then you also get the support. So if you want to join this online training program, so now 50% discount is available. If you want to join this online training program, just simply contact in this WhatsApp number, also contact with this email, then just complete your registration. So today is no more. Thank you for watching that. Stay happy, stay safe.